Hello students, good morning. Good morning.
Good morning,
Good
sir.
morning.
Good morning, sir.
Okay. So today will be the third lecture on unit number 2. We are unit number 2. This will be the third lecture. So in the last lecture we have seen how the embedded systems can be used for IoT. We have also seen what are the embedded systems. Then we have seen the types of embedded systems according to the functionalities and according to the microcontroller or microprocessor to be used. And we have seen some advantages and disadvantages of embedded systems. We have also seen the applications of embedded systems. So today will be the third lecture on unit number 2, and we'll be dealing with some more points like IDE, how this IDE can be useful. So let us start one by one the concepts of the embedded systems for IoT. So let us begin with the same slide which we have already seen. I always like to make you remember that this slide is very important as far as the understanding is concerned. So we know that a system is nothing but the arrangement, all its units assembled together by accordingly the set of rules. And embedded means something that is attached to the another thing. And embedded system is the system that can be thought of as computer hardware system having software embedded in it. An Internet of Things is nothing but a network of physical objects or person called as things that are embedded with software, electronics, network and sensors that allow these objects to collect and exchange the data. So the main motto is that you're building an embedded system in which you're going to share the information, you're going to collect and exchange the data or the information. That is called as the Internet of Things. And then the next question arises that how this embedded systems can be used for Internet of Things. We have also seen the importance of this chapter, that is embedded systems is going to be a cornerstone for the deployment of many IoT solutions. Major players in embedded are aiming to bring these transformations in products to take the advantages of growing IoT market. So obviously, a lot of players, a lot of industries are jumping into this embedded systems so that they can transform their products with the help of the IoT market. Then the embedded systems in IoT applications actually networks a lot of applications, including networking hardware to the home automation. So there are a lot of things that comes into picture. So a lot of players are in the market which are using the embedded systems for IoT. And now we are going to see the next point, which is called as the IDE. Now this IDE is the integrated development environment. Now this enables a programmer to consolidate the different aspects of writing a complete program. So it will provide you the platform for writing the complete program. So normally you do have IDs. So we are going to see in the next slides some of the IDs which are present here, which can be used to develop applications. So you can write a complete program in order to develop applications. IDE increased programmers' productivity by combining the common activities of writing software into single applications, that is, editing source code, building executables, and debugging. So, obviously, IDE is going to help the programmers to combine some of the common activities to develop single applications by writing a lot of programs. That means writing softwares. We could say writing programs that could be useful for editing the source code, building executables and debugging. Even you can edit the source code, even you can execute the .exe files, as well as you can debug it. That means you can troubleshoot the program which has been written. So it provides you the environment, or the platform for writing a lot of programs for single application. IDE presents a single program in which all development is done. So I was saying that there are a lot of programs combined into a one single program. and in which the development can be done. So this is what the advantage of IDE, that is integrated development environment, is there. This program typically provides many features for authoring, modifying, compiling, deploying, and debugging software. So it is such kind of platform which helps you to modify your programs, to compile your programs, to deploy the program, as well as debug it, so that you can also find out what are the errors in your program in order to develop a single application. Remember, for a single application, it gives you so much of features, so many of features that will help in order to develop a single program for a single application. It provides the facility to computer programmers for software development. Some IDEs contains compilers, interpreters, or both. So some of the IDEs contains itself the compilers or interpreter or a combination of both. Now, IDE is actually a software for building applications that combines common developer tools into a single GUI. So you know that's a graphical user interface is like whatever that we've been displayed on the screen. So graphical user interface is nothing but under which you're inside which you're writing a lot of program, and these programs are executed with the help of display on the front panel, that is the graphical user interface. An IDE typically consists of source code editor, local build automation, and debugger. Now, in case of source code and editor, a text editor that can assist in writing software code with features such as syntax highlighting, providing language specific auto completion, and checking of bugs as the code is being written. So actually source editor, you know that in any software you have an editor there. So editor is for writing the program. You can edit your program, you can write your program, and then you can compile your program. At the same time, you can run your program. So for that thing, the editor is always there. For example, I could say that I could take the C editor, or I could take the example of MATLAB editor also, where the source code is written and then it is executed uh, to display the results. Sorry. Then second is the, even you can edit it, even you can modify it, also you can check the bugs as the code is being written, so you can come to know the syntaxes as well as we can do the bugging as the of the code. Then second is the local build automation, the utilities that automates simple repeatable tasks as a part of creating local build of a software for the use by the developer. Now actually local build automation means the tasks that are repeatedly carrying on, it will build a software of the repeated tasks so that it can repeatedly do the task with the help of that software. Then third one is your debugger. Now a program for testing other programs that can graphically display the location of bug in the original code. That means that you can write a program of a debugging. Means a program that could debug the other program. Like debugging is actually what, when you write down a program, there are some syntax errors, there are some logical errors into it. Now, in order to check out the syntax or logical error, you need to debug the program. You know, the debugger tool is used. Now, in this case, you can write down a debugger software. You can write down the debug program in order to debug the other program. So you can write down your own program for debugging purpose, which could be executing in order to debug the other program. So that means it is a program for testing other programs which can graphically display the location of the bug, and also it will also display the location of the bug in the original code. So IDE is having actually typically three parts: the source code editor for editing, compiling, and execution; for local build automation, that is for carrying out the repeatable task as a part of creating local build; and debugger, that is used to debug or find out the location of bug in the original code. Common ID features are meant to help the developers organize their workflow as well as solve the programs. Matlab, if you are having a lot of problems, you can solve it in ID. It is also the feature that are meant to help the developers to organize the workflow. That means what is happening, there are a lot of programs, that are written in order to for single applications. Now when these programs are written, they need to be organized. They need to represent a single workflow. That is possible only because if the developer could organize that workflow. So while writing the code, there will be some kind of human errors in real time. So at the same time, the code could be executed, as well as they could find out the human errors easily in real time basis. So IDE actually provides that environment to find out the human error as well as bugs that is been in real time. So it not only helps to organize the workflows and solve the problems, but it also helps to find out the human error as well as bugs in real time. So this is a very, very important feature of IDE. Because utilities are represented by a single GUI, developers can execute actions without switching between the applications. So this is also very important. Like if I want to have a single GUI, developers can execute action without switching between the applications. So like if I'm executing one application and there is also another application. So if I want to execute the other applications as this application is running, you can easily, there is no need to switch between the applications. So this is also a very good feature of IT. Syntax highlighting is also common in most of the IDs, which uses visual cues to distinguish grammar in the text editor. So obviously, highlighting the syntax in the text editor is also possible. Then some IDs are additionally include class and object browsers, as well as a class hierarchy diagram for certain languages. So you know that there are some kind of hierarchy diagrams which normally the IDE provides for certain languages, and that is possible with the help of IDE. Now these are some kind of popular kinds of IDs. The popular kinds of ID means the number of supported language. Some IDs are dedicated to one language, and so are the better much of the specific programming paradigm. For example, IntelliJ, for instance, is known as primarily for a Java ID. Other IDs have broad array of supported languages, all in one, like Eclipse ID, which supports Java, XML, Python, and others. Now, see, when the IDs are developed, there is a supported language to develop this. So ID, if we can take case of an Eclipse, then it supports Java, XML, Python, etc. So like Java, most of the time is supported language for the ID. Then second is supported operating system. A developer's operating system will constrain which IDs are viable unless an ID is a cloud-based. And if the application being developed is intended for end user, the specific operating system, this may be an additional constraint. Then automation features. Even though most IDs include Even though most IDs include three key features of a text editor, build automation and debugger may include support for additional features like refactoring, code search, and continuous integration and continuous deployment tools. So this is also a very important feature of an IDE, that it can go for a refactoring, code search, and continuous integration and continuous deployment tool. Debugger many automation and debugging is the most important feature of ID. Impact on system performance. An ID's memory footprints may be important to consider if developer wants to run other memory intensive applications concurrently. So I said that if two of the applications are running, you does not need to switch between the applications. You can execute one application and then you can also execute the other application at the same time. Plugins and extensions. Some ID include the ability to customize workflow to match developers' need and preferences. So it can manage, organize the workflow so that developers' need and preferences can be understood. Now, various IDs for the development, embedded development. Now, for embedded, what we have seen up till now is that ID is the environment, integrated development environment, which helps the developers to develop applications by writing software programs. So this is what the ID is. We have also seen the features of IDs. Now, these are the various IDs for embedded development. There are various IDs like available in the market. Is some of them are as follows, like Eclipse, then Kale, Arduino, NetBeans, Komodo, MP Lab, Code Composer, LabVIEW, or Microsip for PIC. So these are some of the IDs in which, out of which we are going to see two of the IDs. One is Eclipse and the other one is Arduino. Whereas Kale is the ID is not free. Eclipse is free, Arduino is also free, Kale is not free. So we'll see some of the IDs examples, how they work out to be. So let us consider the Eclipse. Let us consider the Eclipse. So it's an open source ID that has major factor in the software industries because it offers developer a free comprehensive ID. So Eclipse is one of the free ID. It's an open source Eclipse ID. It offers the embedded system developers for very specific development tool to be easily developed, integrated and deployed within the embedded system. So it can develop a very specific application within the integrated and can be deployed within the embedded system. The structure of the Eclipse is like analogous to a car. So if you could understand how Eclipse work out, then you can take an example of the car. See, the Eclipse platform can be seen as a car having a framework, and everything that is plugged inside that car is nothing but the IDE. So Eclipse platform can be seen as a framework of a car, and everything else is plugged into that framework, with resulting product being a complete running development environment. So जो last में जो result रहेगा वो completely running development environment होगा. तो Eclipse का जो framework है वो कार के framework के जैसा है platform, और उसके अंदर जो भी सारी चीजें plug in की गई है ये दोनों मिलकर आपको एक development environment देगा. This plugin can essentially to the environment. Example engine of the car. So this plug in can be, अभी उसमें से कई plugins होंगे, बहुत सारे plugins है. इसमें से engine एक plugin है जो कि essential part है. कुछ plugins इतने essential नहीं होंगे. यानी what I want to say is that if you consider a car, in the car there are different plugins. If the car is having a framework and inside there are number of plugins, so out of which there is one plugin called as music, which is not so important, which you can avoid also. But engine is one of the plugins that is also important. So there will be some of the plugins that are essential to that environment. Some of the plugins may not be essential. So in both the cases, you can work with the framework of the Eclipse platform. So you can see that there is an Eclipse platform and rest are all plugins. So what is the Eclipse platform? It is having the workbench, JFace, SWT, help, team, debug, workspace. Workspace is the space that is for executing the syntaxes. Then workbench, you know that it's a repeated carrying out the task, and this is the platform runtime. So you can see that there is an Eclipse platform and all the other are plugins like another tool, your tool, their tool, and like plugin development environment, Java development tools. So all these tools are plugin, and out of which some may be essential and some may not be essential, but it will be having the framework in which the plugin will be there. So the platform will be provided by the ID. So this is what the Eclipse is about. Now let us see one more, that is Arduino. Arduino is also one of the open source. It is inbuilt in the Arduino kit. So this is having the inbuilt ID. It is also an open source electronic platform ID based on easy to use hardware and software. This ID runs on Windows, Macintosh and Linux operating system. It is available for extensions by experienced programmer. It is a single board microcontroller. It can sense environment by receiving input from varieties of sensors and affects its surrounding by controlling light, motors and other actuators. So Arduino is a very simple kind of and IDE platform. It is an inexpensive, and the Arduino software can be expanded through C++ libraries. So you can see that the Eclipse is an IDE environment which you need to execute on a computer, which you need to run on a computer. But in case of Arduino, the Arduino IDE is inbuilt with the Arduino kit. So this is the difference between two. So up till now we have seen IDE, and we have seen that this IDE is an integrated environmental development. We have seen how different IDEs are there in the market. Now, after understanding the IDE, we'll move on to microcontroller-based embedded system. Now, this is a very common kind of an application. You can see that you have seen in third year also about how microcontroller can be used for the embedded system. So I have taken a very simple application here. I have considered that there are a lot of sensors in the let us take an example of an agriculture. So there are a lot of sensors being there across the plant. So there is a plant in the agriculture field. So there are the moisture sensor. Then second one is the water sensor. Then the third one is the plant disease detecting sensor. So there are a lot of sensors. These sensors, also humidity sensor. Humidity sensor is also there, which takes the information from the air. All these sensors will be connected to a single sensor conditioning circuit. Now, what is happening? The sensor will always give you a very small voltage, that is in millivolts. So it has to be conditioned because it's a raw information that has been collected from all the sensors. So this information has to be signal conditioned. So signal conditioning means it could be amplified, it could boost the quality of that signal, and it could also boost up the voltage level of the signal. So this millivolt signal is being carried and converted into a voltage signal for the sensor conditioning. Now, when it is been taken sensor conditioning, it is an analog signal. So it's a continuous signals. This analog signals is given to the microcontroller, which is having an inbuilt ADC. So the signals will be converted into the digital, and then it will be given to the microcontroller. Now, this microcontroller will carry out all the functions that is been necessary. Then it is given to the output interface, and this will be displayed. This will be displayed to the indicators, but at the same time it will be given to the actuators, where you will be having the reference voltage level, या फिर reference input level, that is coming to the actuator. So it will see whether the microcontroller output and the reference level output, if they are matching or not. So if they are not matching, then the corrective measures can be taken. So accordingly, you can use microcontroller based embedded systems. You can write down any examples. That may be the LED glowing, that may be motor control, that may be uh, switching on and off of the motor as soon as the water level is indicated. I could also give another example, like I'm having the water tank on the water tank, and it is as what I'm telling is that there is a water level in the tank, and the sensor is there. The sensor will keep on sensing the level of the water. As soon as the level of the water goes down, the sensor output will be 1. As soon as it will be 1, the motor will be turned on. So the program is written in the microcontroller that the level of the sensor, the level of the water is sensed by the water sensor. It is given to the microcontroller. So microcontroller accordingly will take the action and will turn on the motor, because as the level of the water is below the reference level. So this is also an example of microcontroller based embedded system, that is a water level indicator. So there are different applications you can develop. This is one of the simple applications of microcontroller based embedded system. Then there is also a study of Linux based embedded systems. So today Linux can be found in embedded systems in many sizes, from mobile phones, home appliances, or vehicles. Many factors contribute to Linux popularity, such as it is an open source. So now Linux based embedded system means you have to study first of all the Linux, how the Linux could be useful for the embedded systems. So there are many factors which actually contribute to the Linux popularity, such as it is an open source, very strong and committed community maintain and improve Linux regularly. So obviously, as it is an open source, a lot of people keeps on working it and developing it. So it is in uh, always in a flow. It is very flexible and supports any hardware architecture you can imagine. Because it is deployed in millions of devices, its code is constantly tested in many different scenarios. Hence, I could say that Linux is robust. This is a very important line as far as Linux is concerned. As it is deployed in millions of devices, its code is constantly tested. So the code is always been executing. There is every day there is an improvement, updation in that, and henceforth, it is constantly tested. It is not like the others where once you have developed it and then you don't see it, but it is constantly tested in many different scenarios, and hence I could say that Linux is a robust operating system, and that can be useful for the embedded system. It is supported by the huge ecosystem of the software that consists of both runtime software and development of tools. Now we can take an examples of the Linux-based embedded systems. So now we can take three examples here. You can see these examples. First, in a flight entertainment system. So in a flight, you can see that Linux-based operating systems can be used. Linux-based applications can be used. For example, Linux is particularly suited for in-flight entertainment, but it's simple, not weighed down by the accompanying programs, and hence easily adapted to many environments. So as far as in flight, if there is any entertainment system, so you can imagine that it is a Linux-based embedded system. Then second is Tim Hortons Cafe and Bake Shop. This is a very famous bake shop. We started first using Linux-based operating system for an embedded systems in order to display the messages that what is available, what is ordered, what to be ordered. So that information could be displayed, and that is Linux-based embedded systems. Then third one is a gas station pump. The server displays the message of Linux bootloader. Obviously, the Linux bootloader is first displayed, and this gas station is powered by the Linux Ubuntu distribution with kernel 2.6.35. So these are the three examples where Linux could be useful for embedded systems. Now, these are some of the components of Linux-based embedded systems. So these components are first the root file system. In root file system, you can see that there is an application and system program, whereas there is afterward there is a Linux kernel, then there is a bootloader, device tree, and then the hardware. So we'll see one by one how these are developed. First is bootloader. So you know where is the bootloader? That is above the hardware. So bootloader is the software executed to power up, to set up hardware to run the operating system. So in order to power the hardware, bootloader is used. Now second one is the device tree. So where is device tree? Exactly beside the bootloader. So device tree is a tree data structure with nodes that describe the physical device in the hardware needed by Linux kernel to initialize properly the device drivers. So device tree is nothing but that describes the physical device in the hardware and that needed to be initialized. So for initializing purpose, the hardware initialization can be done with the help of the device drivers, and that could be done with the help of device trees. Then the third one is the Linux kernel. So you can see that the third block from bottom is a Linux kernel. The operating system code provide all the services to manage the hardware resources. So it is the code that is written. Actually, Linux kernel is actually what the operating system code that is providing all the services in order to manage the hardware. That is for the Linux kernel. And then the system programs. So system programs is user-friendly utility to access the operating system services. Next come the application, software implementing the functionalities to be delivered to the embedded system user. So application is that development, that is the software implementation functionalities to be delivered. Then root file system is the container of the Linux kernel configuration file, the system programs, and the applications. So these are the all parts of the Linux-based embedded systems components. So I do feel so you might have understood. So let's little bit revise it from the start. So here we are. IDE is nothing but the integrated development environment that enables the programmers to consolidate different aspects of writing a complete program. Then IDEs actually presents a single program to which all development is done. Some IDEs contains compilers, interpreters, or both. It is having three parts: source code editor, local build, automation, and debugger. A text editor that that can assist in writing the software code as well as checking the bugs of the code. Local build automation, it automates simple repeatable tasks as a part of creating local build. Debugger is to find out the location of the bugs in the code. Then it also helps developers to organize the workflow and solve the problems in real time, also find out the human errors in real time. Then it can execute actions without switching between the applications. It can distinguish grammar in the text editor, and also as well as it includes class and object browsers as well as class hierarchy diagram for certain languages. And these are some of popular kind of IDs. Like first of all is that Eclipse ID, which supports Java, XML, Python, etc. Then if application being developed is intended for the end user with specific operating system, this may be an additional constraint. An automatic feature is to having three key features: a text editor, build automation, and debugger. Then ID's memory footprint may be important to consider if a developer wants to run the memory intensive applications. And some IDs include the ability to customize workflow to match the developer's need and preferences. And these are the some of the various IDs that is useful for embedded development. Some of them are Eclipse, Kale, Arduino, NetBeans, Komodo, MPLab, Code Composer, LabVIEW, Micro. Code Composer is actually the ID that is being useful for DSP processors, and LabVIEW is also useful for the hardware. So these are all IDs. And we have seen this Eclipse, which is an analogous to the car. So you can see that the Eclipse platform can be seen as a framework of the car, whereas all the plugins, so the framework and plugins together will be a complete development environment. So this is the Eclipse platform which has been there. Then understanding the Arduino. So Arduino is an ID is inbuilt in Arduino kit. It is inexpensive, and it's a single board microcontroller. It's an open source electronic platform. Then this is the example of microcontroller based embedded system. You can take different examples. So these examples are that a lot of sensors are there which is sensing some parameters giving to signal conditioning circuit. Then it is given to ADC in microcontroller, inbuilt microcontroller. Microcontroller is giving the output accordingly. It is indicating what are the values as well as it is matching up with the reference values to get the output. Then this is the Linux based embedded systems. Example in flight entertainment system, then in bake shop and in gas station pump, most of the systems are Linux based systems. So this is the Linux based components, embedded system components, hardware, bootloader, device tree, Linux kernel, system program, applications, etc. So these are the working of it. So I hope you have understood this. Yes, students, have you got it? Yes. Hello. Hello. Hello.
Yes, sir.
Definitely. Okay. We'll take